and my wife is telling me that the sound is not working. Hopefully it is now working. I think it is. I had the I had myself muted. Should have known that was going to happen. All right. So as we start back up again, sorry about that. This is what happens when I go live. I always get a little bit of confusion here. Oh, thank you, Christina. You also noticed I have no sound. So sound's back. We should be good to go. And yeah, so in terms of what we're going to talk about tonight, we're going to talk about how the impacts of Henri are not going to be nearly as significant as they could have here in southern Vermont, although just to our south and west in the Albany area, northern Catskills, southern Adirondacks, they are looking for some of those impacts that we were talking about potentially here. Thankfully, those are not, it doesn't look like going to happen for us. We're going to see much more in the way of just some rain. We will still get some heavy rain as the storm pulls back to the east tomorrow, but it's not going to be real significant. Then I'm going to talk to you a little bit about why the storm took kind of the interesting track that it took and what steers tropical storms. So if you have some interest in that, then we're going to talk about what's the difference between a tropical system and a non-tropical system. So this is a bit weather nerdy. So if you've got specific questions, let me know. Okay. Looks like everybody was just asking questions about sound. Awesome. All right. Yeah, so let's take a look. First, let's just take a look at what's going on radar-wise. Hey, the comments did pop up there. They're a little small. Actually, let me change that real quick. Don't do enough of these live updates always to know or to be able to always see them. There we go. Look at that. Don't always do enough of these live updates in order to see, and I bet I can change that to the other side of the screen. I know this is live breaking, huh? Okay, well, I guess it's going to stay again. Here's radar. Radar does not look bad. As you can see, most of the heavy moisture, let me lean back here a little bit, has moved to our west, but you can see Henri's westward movement has mostly stopped. So Henri came up the coast to kind of a left-hand corner. As soon as it hit, it came on shore over the tip of Long Island and Connecticut today as a tropical storm, and then it kind of headed in this direction. It's going to eventually stop moving west and then kind of move back to our east. And as that happens, what's going to happen is we will get some of the heavier rain to swing back through southern Vermont. But at that point, we'll have lost enough energy and enough moisture that I think we'll be all right in terms of our in terms of what happens in terms of flooding issues and things like that. We could still see a quick inch or two of rain in a relatively short amount of time, which maybe would make some some ponding on the roads and things like that, but really no big deal. Nothing that we should really have any issues with. So the good news, headline news is Henri, it doesn't look like in southern New England's going to cause problems. Now here across just kind of the Albany area, particularly down here across the Catskills and the Poconos, where there's some interaction with an upper level low pressure system as well. That's where the flooding rain potential kind of ended up. There was always going to be a spot that got flooding rain with Henri with this kind of a system, especially with the slowdown. But the question, and it looked like we could have been in that spot, and that's why 2 days ago I was pretty nervous. We have all the right kind of setup for it. Thankfully, the storm tracked in such a way that we really got out of the bad flood potential area and are kind of just in the heavy rain potential, because there is going to be some places down here that probably get 7, 8, 9, 10 inches of rain. That would have been plenty of rain to cause like an Irene type event here in Vermont. Thankfully, that didn't happen. Nobody wants to see that again. I had just moved here. I only lived here about a year when Irene happened, and yeah, nobody wants to see that. It was not good stuff. So hopefully they're weathering the storm pretty well down here in northern New Jersey and northeastern Pennsylvania. So satellite imagery shows you, this actually I think is a really interesting picture to show. As a matter of fact, if you had seen, already looked pretty impressive. It was well defined here, and you can already see that the energy, especially these the deeper colors here, represent where the thunderstorm clouds are highest, and it really shows you how quickly a storm loses the most of its energy early on once it comes on shore. And we're going to talk about why tropical systems do that and why wintertime storms don't do that, why they can go over land and why tropical storms can't. I know some of you have probably known, if you're a weather nerd, you've known this stuff before, but this is a good system to talk about that with. It's also an interesting storm track because it was going west, then it's curved to the north, and then we kind of hooked left, and now we're going to hook back east and eventually kind of go east-northeast, kind of straight across Massachusetts probably, and then out to sea over the next couple days. Now, a lot of that, as you can see, we're already losing a lot of energy, so that's why, even though we will get some of that heavy rain, the heavier rain that's happening to swing back through, it won't be as heavy as it currently is now. So why did the track do what it did? Okay, so this is 500 millibars. Sorry, I'm in my office with all these lights on. It's like 85 degrees in here, so if I'm sweating a little, sorry about that. Yesterday, about 24 hours ago, Henri was starting its northward trend, and 500 millibars is a good place to look. It gives it's a kind of a middle to upper middle part of the atmosphere, and it gives you a good idea of what the sometimes what the median wind is doing. So essentially, a tropical storm will follow the median wind. Now that means sometimes the winds are aloft and down close to the surface are going opposite of each other. We call that wind shear. That's not great for a tropical system for a bunch of reasons. But it's usually the mean over the entire column of air that can tell you where things where a storm's going to go. But sometimes as an approximation for that, you can look at this 500 millibar map, and it shows what was kind of happening yesterday. And that was we got into these stronger southerly winds because we have a cutoff low kind of over West Virginia, Western Pennsylvania, and we had, as part of that, we've had this a ridge across the east, but a cutoff low kind of stuck underneath it. And so what happens is around a high pressure system or a cutoff, around a low pressure system, we obviously see the winds go counterclockwise like this. And so aloft, first we had southerly influence, and then this counterclockwise flow wanted to push the system back to the west. You also had this kind of developing nose of a little bit of a ridge, which is sort of connected to the major part of the ridge here, which is kind of nosing in and also wanting to curve the storm around this way. So sometimes it can feel like hurricanes just do whatever they want to do, that they're not controlled by the bigger weather pattern, but they are controlled by the bigger weather pattern. The reason they sometimes do strange things as compared to more traditional storms that we think of for winter storms and things like that is because of the ways that tropical storms develop and where they develop. And it's usually much more subtle influences that cause tropical storms to move around than the kind of things that cause winter storms to move around. And that's why winter storms do tend to basically form, we're going to talk about this, but essentially they need an air mass or a temperature difference to clash. And so they will often form where there's lots of air temperature differences. That's where they get their energy. And those tend to happen in the same places, and they tend to follow the same kind of pattern. So we get a lot of them right up the East Coast because you have during the winter a relatively warm Atlantic Ocean here and a relatively cold continent, and that clash causes the storms to happen. But hurricanes don't need a temperature difference. They have a completely different way that they work in terms of making things happen. So this was what was happening 24 hours ago. Then 12 hours ago, whoops, sorry, let me stop showing that one. You can see this upper level low actually as somewhat as a result of what Henri was doing. Henri's also making some influence on this. It's kind of sucking it underneath. And then that's wanting Henri to even more kind of start to curve. So you see Henri's basically at the end of its straight north path, and you can see we've got some winds aloft that are kind of going to the north, are going from the southeast to the northwest. And then when it comes on shore, you can see that the two are actually starting to combine, and that's actually what's going to happen with the storm now. It's kind of combining with this upper level low to create a more traditional, what we would call extratropical system. And the reason that's not going to be super strong, if this was happening in the fall, like what happened with Sandy may have happened. This is actually relatively similar setup to what happened with Sandy. But the difference here is there is no cold air. Sandy had cold air to tap, so that when the storm interacted with the upper level low and converted from a warm core and basically transferred all that energy, all that moisture onshore, it then also had a chance to form a really, really strong, all this warm, moist air and a really cold air behind it, and it was able to form a really strong extratropical storm, kind of as a hybrid storm as it came on board. It was basically transitioning as it came on board, and it still had the hurricane force winds. That's why New York City saw the damage they did. And the proof of that was some places in West Virginia from Sandy got 3 feet of snow in the upper elevations in West Virginia because there was enough cold air for that to happen. This time of year, there is no cold air. There's no cold air here in Canada. There's relatively cool air. But this storm doesn't have that kind of energy. So as the tropical system dies, there's not really any supporting energy from a non-tropical system. There is a little bit of a spin in the atmosphere, but nothing that's too exciting, nothing to write home about. So back to the big question: where does a tropical storm get its energy versus where does a regular extra tropical storm gets energy? And really that has everything to do with a tropical storm forms. It gets its energy entirely from converting water vapor into liquid water. So what happens? think this is kind of in the opposite direction. When you boil a pot of water and it gives off steam, you're putting lots of energy into the water, and eventually it heats up to its boiling point, and then eventually that creates steam. So you have to put lots of energy in to make that happen. Well, when you turn water vapor back into water, which is what happens when clouds form and when rain droplets form, that energy that had to go into it to make it into water vapor comes back out in the form of basically heat energy, which the atmosphere will convert into rising air, and then because of the way that the Earth spins, it turns it into rotating air, and all that energy eventually ends up being ends up as wind energy, and that's why tropical storms can form really strong winds. But there's no temperature difference across them. So across the surface of the ocean, the temperature is almost exactly the same. And you'll notice that's true today, right? It feels very tropical. It's super humid out there today as we've gotten into this system. There's no cold air like I was talking about to kind of as an extratropical system would have. Now, an extratropical system gets its energy by having cold air and warm air clash, and the atmosphere in any fluid, which the atmosphere is a fluid basically. Anytime a fluid comes together, if you put cold fluid next to warm fluid, they will find a way to equalize that. And so in the atmosphere that happens, and so the warm air wants to head towards the cold air wants to head towards the warm air so that they can equalize the temperature. And again, because the Earth spins, we get a spin up of a storm, which causes rising air, which means that we get precipitation and things like that. But the energy is coming from the temperature difference, not from simply turning water vapor into liquid water. So that's why a tropical system needs two things. It needs, first of all, to be over water, because it's got to be, you're turning lots of water vapor into lots of liquid very quickly in order to maintain this kind of energy. As soon as you cut that off, then you therefore no longer have the energy, and a storm will just spin itself out. It takes a little while for the rain to rain out, but the winds spin themselves out very quickly, because all of a sudden, instead of those two things aren't in balance anymore. You're not putting enough energy in to balance how fast the winds are. And so it needs to be over water, and it needs to be over warm water, usually above 28 degrees C, 27, 28 degrees C, Celsius, in order, which is like 80 degree water, 82, 83 degree water, in order to get enough so that the warm, moist air that's flowing in is warm enough to give up enough heat as it rises. Basically, as the air rushes towards the center of that low pressure system as it develops, it has nothing to do but rise, right? The air just can't pile up in the middle as it gets pushed towards that low pressure, so it rises up, which is what this dynamic shows, right? Air rushes in at the surface, then it rises up, and we get kind of in the middle, and then it gets finally hits the tropopause, which is where the atmosphere gets stable, which happens about 60 to 65,000 feet in the tropics, and then the air kind of eventually, because the atmosphere is stable at that point, the air stops rising. Basically, it's stable because, for a bunch of different reasons, the temperature, instead of continuing to go down and encourage air to move up, this temperature starts to increase. And if the temperature is increasing as you go up in the atmosphere, then that's a very stable layer. Think of that like an inversion like in the late winter, you'd have an inversion, and that's why like the smoke gets stuck in the village or something like that. If you're down by the river and it's a cold morning, but there's it's warmer aloft, the smoke will just get stuck down here because it can't go up, because the air can't really move up if it's warmer above it. It inhibits that. So anyways, it gets to the tropopause and then it dissipates out. So that's essentially what happens with a tropical storm versus so when they come onshore or they go over cold water, which already did both, right? Because the water, as you get closer to New England, it's the ocean water. I was just at the ocean. That's why I didn't have any internet access these last few days. It was warm, but it's not 80 degrees here across New England, and not even south of, and not even, it's warmer than I was in the coast of Maine. It definitely wasn't 80 degrees. But even down there in Long Island and off the Jersey Shore, the temperatures and the water's not that warm. So as soon as you don't have enough warm air, then you're going to start to spin the system down. And then once you get over land, it cannot sustain itself. It can't suck in enough moisture. It will still be sucking in air, and you can tell it's super humid out. That's why I'm sweating. And so the air will come in and then push the air up, but there's less of that energy being added into the storm than it's dissipating through the wind. And so as soon as that happens, the storm starts to deteriorate. It's a relatively simple process. Obviously, the details there are often pretty confusing. So, but anyways, I just wanted, this is a good storm to talk about that, especially since it's essentially missing us. So if you missed the beginning of this, or excuse me, if you missed the beginning and you wanted to see, here's my big highlight. We're basically good in terms of flooding here across southern New England. Not so much for the Poconos, for the Catskills, even up into the Albany area. Some of these areas here are kind of under the gun. This will swing through again tomorrow. We could see off and on heavy rain through probably midday, even afternoon tomorrow. There'll be lots of periods of dry, and a lot of places around us here haven't gotten that much rain at all yet, but I don't think we'll have any problems. Any problems we would have would be if we got briefly heavy, like 1 or 2 inches of rain in a 2-hour period, and then we might have a few issues with ponding of water on the roads. The rivers will be fine here in southern Vermont. It's really like I said, a northeastern Pennsylvania, central New York kind of issue because of where the storm tracked, essentially. Did want to give you just kind of our summary of my impacts from earlier today. Flooding slight to basically none for a problem today. Wind continues to be, we've had some gusts, I think, to about 20, 25 miles an hour. They might get a little gustier, but not much, so I wouldn't worry too much about that. And rainfall, it could rain heavy here and there. It's also going to be very humid. So, and it will be kind of gray for the next couple days. It's going to take, Tropical Storm Henri is going to take its time getting out of here. So that's what is going on. That's your little lesson tonight. I hope you found that interesting, even though thankfully we don't have a lot of details in terms of where flooding is going to happen to go over. I'm really glad about that. Nobody wants that. Certainly for those who are experiencing some of that, we just kind of keep them in your thoughts over the next couple of days. Could be kind of a tough couple of days in some of those counties in northwestern New Jersey and in the Poconos where they are getting a lot of rain right now. And be somewhat thankful that that's not us this time. And as somebody on the fire department, one of the things I learned is we do this relatively frequently because there's threats for, and our fire station is right on the river, like most fire stations are in southern Vermont. And so we get used to getting ready for flooding, doing the little things you can do, then recognizing, sometimes you do it and nothing happens, and we're thankful when that happens. And sometimes, unfortunately, you get ready and then something does happen. So this time, thankfully, that kind of stuff didn't happen. As we have questions, always going forward, let me know. One of the things I've thought about doing over time, if there's interest in it, is to sometimes do these live updates, or not necessarily live updates, but live events where I do talk about weather. It's a little hard. I like to do it more in a classroom setting, so I don't know if maybe Zoom would work for something like that, but I love kind of talking through and teaching weather, and I like it to be interactive. I know that's a little awkward and weird through the YouTube comment section, but I like to teach in that regard, and in that way, not so much just talking, although I'm obviously apparently good at that as well in terms of just being able to talk forever. But, okay, that's probably enough for you tonight. Try to stay safe out there. Still probably a good idea to, if you don't need to go out tomorrow, just let it kind of be a wet day. And if keep an eye on that radar to make sure that there's none of those heavy bursts coming down. But otherwise, I think everybody should be all right, and have a safe and good week. And now my summer vacation stuff is done, so I will be back with more regular Monday morning forecast for the week. I'm not sure if that's going to happen tomorrow morning. It might be sometime tomorrow. I'll get a work week forecast out, and then have Friday forecasts for the weekend. If you're interested in an early look at those weekend forecasts, I have a list of patrons, and there's if you go to my website, you can see how to get to my Patreon site and support me. And one of the things my patrons get is they get a weekend forecast on Wednesdays. And some of my there's also a Patreon option to get an extended look at the forecast. It's a 10-day forecast every Wednesday as well. So, all right, thanks everybody for joining me. Stay safe out there, and be thankful that it's looking like our weather is not going to be nearly as bad as it could have been with Henri.